So how does the nervous system get super overwhelmed by stress and affect everything? Well, today on Thinking Thursday, we're going to build on what we learned about the nervous system and understand the interworkings so you can see how stress and the nervous system affect the entire body, head to toe. So first things first, if you haven't yet watched my video on the nervous system, go check that out right now so that you can understand the details before you understand the details. I want to take a few minutes to dive even deeper and really see the process of what is happening. Now, the nervous system is quite complex, but there's more to it. There's so much that happens to trigger the nervous system, and that's what we're going to talk about today. Let's dive in. First and foremost, what actually happens during stress? We're going to talk about two types of stress. Acute stress, which is a quick burst of stress. So let's say you are in a dangerous situation and you need to find your way out. That's acute stress. Or let's say you get a phone call that something happened to a loved one and you need to go and make sure everything's okay. Well, your sympathetic nervous system is going to get activated and you're going to deal with acute stress, the adrenaline rush and everything. Chronic stress is when you have stress, persistent, extreme stress that just doesn't go away. And we're going to look at what that does to your body as a whole. So the central nervous system is the thing that triggers this whole chain of events. So during a stressful situation, the CNS, otherwise known as the central nervous system, activates the sympathetic nervous system via a system called the HPA axis. Now, what HPA stands for is hypothalamic pituitary adrenal. We're talking about the hypothalamus, the pituitary gland, and the adrenal glands. So this HPA axis gets activated and quite literally floods the brain with cortisol. So when the brain gets flooded with that cortisol, the main thing that happens is that cortisol increases amygdala activity within the brain for heightened alertness, to make sure that your body is on alert. What's gonna happen now? That was intense, and I meant it to be because that is what happens in your sympathetic nervous system. It gets intense, it gets activated, it's high alert. This reaction of the amygdala on high alert is essential. It is an essential part of survival. That is what the sympathetic nervous system is for, survival. And when it comes to survival, what is happening is your body is assessing this life-threatening or potentially life-threatening situation. Now, keep in mind, your brain cannot tell the difference between an actually life-threatening situation and a non-life-threatening situation that just happens to be stressful. Not in that instant. Your brain doesn't get a chance to think logically, to really think about it. It's just your body's innate survival instinct. There's another system that works with the HPA axis, and this is called the SAM system, or SAM system. SAM stands for sympathetic adrenal medullary. So this system is activated, like I said, at the same time as the HPA axis. The big difference is not just the activation system. The big difference is that the SAM system acts instantly, very, very quickly, where the HPA axis is slower. It is a slower process. Both are important. Both are essential to activating the sympathetic nervous system because they both release those super important stress hormones. Cortisol in the HPA axis, and epinephrine and norepinephrine in the SAM system. Epinephrine and norepinephrine are also known as adrenaline and noradrenaline. So the SAM system, or SAM system, floods the nerves that control the sympathetic nervous system with epinephrine and norepinephrine. So even though these two systems are different and do different things, they work together to activate the sympathetic nervous system, to activate those nerves that activate everything within that system. So the first thing you'll see in this video is the hypothalamus, the pituitary gland, and then we're going to zoom in down to the adrenal glands, which sit directly on top of the kidneys. From here, corticotropin-releasing hormone gets released from the hypothalamus, and it then triggers the pituitary gland to then release adrenocorticotropic hormone. So then what happens? The adrenal glands get triggered by the pituitary gland, which just sent the ACTH, and says, hey, adrenals, release some cortisol. Get this process going. So it releases the cortisol. Now it gets even more interesting, because what happens is called a negative feedback loop. The cortisol gets released into the bloodstream, but it doesn't stop there. The cortisol also goes back up to talk to the hypothalamus within the brain and tells the brain either, hey, there is enough cortisol, the stressful situation has resolved, we're good, don't release any more CRH to send to the pituitary gland. Or it says, hey, we need more cortisol. Let's get going. Send another message to the pituitary gland. Let's go. Then the pituitary gland says, oh no, we got to send another message to the adrenal glands. So let's send that ACTH message to the adrenal glands to get that cortisol going. So then the pituitary gland does that. The adrenal glands say, oh no, we need to now release some more cortisol. So what happens? Cortisol then gets released into the body and then goes back up to the hypothalamus, tells the hypothalamus in chronic stress, hey, we still need more. And it becomes this loop, this never-ending loop. And you will see what that looks like in a moment. Now, for the SAM system, it's a very similar concept. Something gets triggered and a process occurs, but it's different. What happened with the HPA axis, the stress triggered the hypothalamus to release a hormone to send a message to another gland, to release a hormone to send a message to another gland to release a hormone. In the SAM system, instead of the hormone process, the hypothalamus receives a neuron signal. In this video, there's a line down the center of the body, that yellow line. That right there is the spinal cord. This is the tube that is protected by the spinal bones, the vertebrae. Down at the bottom are the adrenal glands again, because they are just as important in the SAM system as they are in the HPA axis. Now within this system, instead of releasing hormones, the hypothalamus receives a signal from a neuron. And that is what I'm going to call the stress signal or distress signal. The body saying, hey, we have a stress situation going on. And it sends this signal through a nerve or neuron into the hypothalamus. That is that flashing red circle that you see at the top there. That signal then goes down the spinal column all the way down. And here's where things get interesting again. That neuron signal goes directly over the nerve that connects to the adrenal gland. This is a cross section. And what you're seeing here is on the very inside with the blue and red little flecks, if you will, that is called the adrenal medulla. The adrenal medulla is responsible for releasing epinephrine and norepinephrine. The outer part of the adrenal gland is called the adrenal cortex, and that is where the cortisol is released. So the SAM system is just responsible for the epinephrine and the norepinephrine, where the cortisol, that comes from the HPA axis. So then what happens is that nerve signal then went to the adrenal gland, right? It went in there and it said, hey, we need the epinephrine and the norepinephrine, send it out. That's what those dots are right there that you're seeing come out, are sent directly to the nerves that control the sympathetic nervous system. If you go back to my previous video, you're going to see that the nerves in the thoracic region of the spine, that is where the nerves that control the sympathetic nervous system live. And that is where the epinephrine and norepinephrine goes specifically to those nerves. And then that's what triggers the sympathetic nervous system. Now let's look at what acute stress looks like. When we look at acute stress in the HPA axis, as soon as the hypothalamus determines, oh, I don't need to send any more signals to the pituitary gland, as you can see, all of those hormones, body doesn't need them anymore. The stressful situation has disappeared. There you go, acute stress. When we look at the SAM or SAM system, same kind of thing. That neuron sends a signal all the way down the spinal column. It goes to the adrenal medulla. It releases your epinephrine and your norepinephrine, and it goes back to the nerves that control the sympathetic nervous system. And then what happens? Hey, guess what? We don't need them anymore. So the body stops producing these stress hormones. What happens when that stress becomes constant? Otherwise known as chronic stress. Here's a little visual for you to understand what it looks like from a hormone perspective, what chronic stress looks like. It's a little dizzying. Take a look at what this looks like. It's not pretty. Kind of gives you a little bit of a headache, or at least it does for me when I look at it, and it's just constant, non-stop. Everything's just going. You got your cortisol, keeps going back up to the hypothalamus, and back up to the hypothalamus. Hey, send all the messages down. And then the SAM system, same thing. You get that neuron signal, it sends it down, it releases the epinephrine and norepinephrine to the sympathetic nervous system, but guess what? That stress signal is constantly going right back to the hypothalamus, and the hypothalamus has to then send that nerve signal back down to the adrenal glands. So what's happening to your adrenal glands? Well, man, those adrenal glands, they're exhausted because they are releasing hormones constantly, over and over and over and over and over again. Okay, I'm stressed, still stressed, still stressed, still stressed. Here's more hormones. Let's overwhelm the body. I made it that fast to make a point. It feels like that every time. When you're super chronically stressed, it's dizzying. You're seeing the cortisol, the epinephrine, and the norepinephrine, and that's just part of it. Constantly going everywhere and just being released and being released and being released, essentially overwhelming the system. But let's talk for a second about what these hormones do. Cortisol, the primary stress hormone, it does a whole bunch of things. Here are just a few. Increases sugar in the bloodstream. It also then enhances the brain's use of glucose. Now remember, all of these things are good in the short term because it's survival. It's your body's survival instinct. Cortisol also increases the body's ability to repair tissues while suppressing non-essential functions like the immune response, like the digestive system, etc., etc. Keep that in mind when we talk about chronic stress and the sympathetic nervous system is constantly activated. What's not happening? Non-essential body functions or non-survival functions, functions that don't need to be happening when you're just trying to survive. But if it's persistent and none of these functions are regularly working, guess what? Your body's just in survival mode. And all these other things that no longer are functioning, that need to function, like your digestive system, like your immune system, all of these things suddenly stop and you're stuck. Epinephrine, its job is to literally cause that immediate fight or flight response or reaction. For example, the dilated pupils, the increased heart rate, the increased blood pressure, and the energy supply. And norepinephrine works with epinephrine to heighten arousal, to heighten alertness, to heighten focus. It plays a key role in the sympathetic nervous system because it works with epinephrine. They have their own roles. Epinephrine triggers all these things, but norepinephrine comes in and says, okay, now we got to focus. Now we got to be on high alert. Let's do it. And it specifically works with epinephrine to basically heighten all of those things. What I want you to see now is three main parts of the sympathetic nervous system. I showed you a whole bunch in the previous video. Again, go watch that if you haven't already. But I want to focus on three things here: the pupils, the heart, and the intestines. I really want you to see the difference in what happens because think about it. When stress is persistent, and what I mean by that is stress is constant. It's just always there. The sympathetic nervous system takes over, and it doesn't give the parasympathetic nervous system a chance to take over. The parasympathetic nervous system is what your body is usually doing. It's that rest and digest. When you're not in a fight or flight or life-threatening situation, or what your brain perceives as life-threatening. But when your body is stuck in fight or flight and it will not relax and let the parasympathetic nervous system take over so that you can reset, recharge, if you will, not so good things happen. Let's take a look, shall we? The picture on the left is parasympathetic, rest and digest, normal, if you will. The picture on the right is what these three things look like during chronic stress. So first, we talked before about the pupils. Well, what in the world does that even mean? Well, in the rest and digest system, your pupils are normal size. They don't need to be super dilated to let all that light in. Have you ever been to an eye doctor appointment and they dilate your pupils and it hurts to keep your eyes open? You can't read anything because your eyes can't focus. During fight or flight, when the sympathetic nervous system is activated, your body dilates your pupils and it lets so much light in because that's part of the stress response. So a normal or parasympathetic nervous system situation, the pupil is constricted in bright light so that it doesn't hurt your eyes, and it dilates in darkness. But in chronic stress, pupils are persistently dilated, which leads to light sensitivity, difficulty focusing. Your eyes then have to strain because you can't focus, and that's painful. What do you think ends up happening? Headaches. You get muscles twitching around your eyes, things like that, because your pupils are essentially stuck open. Now let's look at the heart. Now you can see in the picture that the heart on the left is just beating normal. It's just, oh, that's nice. Where the heart on the right, when it comes to chronic stress, beating way too fast. You see how fast that is? And that's persistent. When your heart beats that fast, it's kind of hard to breathe. So you have this persistently rapid heart rate, and that is not a good thing. It is hard to breathe. But then what else happens? You get heart palpitations, and I don't know about you, if you've ever had heart palpitations, boy, they are not fun. You get chest pain, chest tightness, chest pressure. You ever hear that phrase, you feel like an elephant is sitting on your chest? It's a real thing and it sucks. Fatigue, your heart is pumping so hard, it is working overtime to send blood throughout your body. You get overwhelmed, you get fatigued, you're just exhausted, and that's pretty awful. And then anxiety and panic kick in. Now let's take a look at the digestive system, and I'm only showing you the intestines because, well, it was just easier for me. If you take a look at the picture on the left, you can see that the normal or parasympathetic nervous system, when that is activated and it's just normal, life is good, going along, no major stress, the intestines are doing their job. They're moving things along, if you will, as they need. But like we said before, what happens during chronic stress? Well, if you're stuck in the sympathetic nervous system, you have persistently slowed intestinal function. So digestion slows, comes to a halt. Suddenly, you're not regular anymore, you're constipated, or you have diarrhea because your body doesn't know what to do with what's in your intestines. You deal with gut inflammation, and that's painful. So when you are stuck in this chronic stress mode, or the sympathetic nervous system, your body doesn't know what to do. It gets overwhelmed and it feels awful. So now that you have this visual and you understand everything that is happening due to the nervous system being triggered, the influx of hormones, the next step in my next video, we're going to start looking at how all of this affects your skin, your muscles and your bones and your body, and how it affects your mental health. From there, we're going to take a look at how this chronic stress situation affects your reproductive wellness. I hope you'll join me. See you next time.